Hi everyone, welcome to my Core 4 OCR January 2008 paper. We're going to look at question 7. I'm doing this particular question because one of my subscribers asked for it. So it just shows if you ask, then when I have time I'll put it on for you. Okay, so let's go for it. The first part says that A bracket sine theta plus cos theta plus B brackets cos theta minus sine theta is always the same as, that's what these three equal signs mean, for sine theta. AKA, if we simplify all this, we get that. So let's have a go at simplifying out the left-hand side. So let's multiply into our bracket. We get A sine theta plus A cos theta plus B cos theta minus B sine theta, and we're told that that's the same as, you can use 2 or 3 equal signs, it doesn't matter, for sine theta. Now we want to try and make the left hand side look like something sine theta, so what we're going to do is we're going to collect together our sine thetas, and that means that we have A minus B lots of sine theta. Okay. We're also going to collect together our cos thetas, which means we've got A plus B lots of cos theta. Now that is always equal to 4 sine theta, and I'm going to give you a clue. There's nothing to stop us writing plus 0 cos theta. You've got no cos thetas and 4 sine thetas, aka A minus B must be 4. So you know A minus B is 4. Not only that, A plus B must be 0 because we've got no cos thetas. Okay, so you have two very simple simultaneous equations. Okay, A is negative B and A plus minus B equals 4. So if we go back to GCSE style for a second, solve these two simultaneous equations by taking them away. So we get minus 2B equals 4, aka B equals minus 2, and A must then equal 2. That means that we can write this expression out again as 2 sine theta plus cos theta minus 2 cos theta sine theta. If you did want to expand that out yourself, you'd see when you simplify it does actually give you 4 sine theta. So you know it's worked. Looking at part 2, we have to evaluate an integral. So it says hence, and that means you're going to use what you've already done. Do not ignore that word, because that question on its own is very, very tricky. Because it's a hence, we can change this to what we just did. So we're going to be finding the integral between 0 and pi over 4. We're going to change 4 sine theta to what we just worked out, which is 2 sine theta cos theta, 2 sine theta plus cos theta, take away 2, and let's just check, cos theta minus sine theta. A simple substitution, and that is divided by sine theta plus cos theta. Okay, now we've got two things separated by a takeaway, and they're both being divided by sine theta plus cos theta. So the first one is divided by sine theta plus cos theta, and the second one is divided by sine theta plus cos theta. So you might see where this is going now. All this stuff is going to simplify quite substantially. And we're integrating with respect to theta, which is obviously very important. So before we integrate, let's just carry out our simple division. You've got 2 lots of that divided by the same thing, so obviously they're going to cancel out. Okay, so the first bit we're just integrating 2, which is very, very simple. 2 theta. Okay, the second bit, I'm not going to lie, it's more difficult. So let's think about what we know to do this one. So we've got 2 theta. This one, can you notice that the differential of sine is cos, the differential of cos is minus sine? Hopefully you've been taught that if you have function over, the differential of a function over the function, in this case it's not f of x, it's f of theta, but it doesn't really matter, then that integrates to log or ln of the angle of the function. Okay, so strictly speaking, the modulus of the function, and that is what's going to happen in our case. The only difference is if you've got 2 lots of it, obviously you're going to have 2 lots of your answer. So our answer for this is quite simple, really. Minus 2 ln of the bottom row. Okay, sine theta plus cos theta. Now we just have to evaluate between pi over 4 and 0. And your question says the exact value. So you have to be very, very careful with that. Okay. So our first bracket is going to be 2 times pi over 4, which is pi over 2. Take away 2 ln of sine pi over 4 plus cos pi over 4. And our second bracket, which we're taking away, is going to be 2 times 0, 0. Take away 2 times ln of sine 0 plus cos 0. So we just have to simplify this. So we get pi over 2 minus 2 ln. Now let's think about this bracket. If you put sine of pi over 4 into your calculator in exact form, root 2 over 2. Similarly, cos pi over 4, root 2 over 2. So you've got half of root 2 plus half of root 2, so that's going to give you root 2. And then you're doing minus 2 ln of sine 0, which is 0, plus cos 0, which is 1. And we all know that log of 1, any log of 1 is 0, because it means what power do we have to raise our base number by to get 0? To get 1, which is 0. So that's going to go. So hence our final answer, pi over 2, take away 2 ln root 2. Okay, we don't need the modulus sign now because we know that root 2 is positive anyway. So you don't actually need that. I hope this video has been useful. Thank you for the question. Remember, any questions that you do have, I will respond to. Thanks for watching and goodbye.